Section 5.2, characteristics of polynomial functions. Here we have a function f of x is equal to negative 2x squared plus 2x plus 4. The first thing we're asked to find is the degree of the function. Now, if you remember from the previous lessons, the degree of the function is the variable with the highest exponent. So if we look here, we notice that we have two variables, x, and we have 1x to the power of 1, and we have 1x to the power of 2. So the variable with the highest exponent would be x squared. So we take our highest exponent, which is 2, as the degree of our function. And you might also have noticed by looking at this that this is a quadratic function. It forms that parabola shape. So by looking at this, you should know that all quadratic functions, all parabolas, have a degree of 2. Now the number of x-intercepts in this case is 2. There's 2 x-intercepts. Okay? Depending on your quadratic function and where your parabola is situated, you could have 0, 1, or 2 possible x-intercepts. In this case, we have 2. Now our y-intercept, as we noted in the previous lesson, is always equal to our constant value. So our constant here is positive 4, therefore our y-intercept is going to occur at 0 and positive 4. And you can see it crossing the y-axis here at 4. Now the end behavior of our unhappy negative parabolas, we notice that our unhappy parabolas always start in quadrant 3 and they always end in quadrant 4. So this is the same for any negative parabolas, so our unhappy parabolas. So our end behavior here would be a movement from quadrant 3 to quadrant 4. Now our domain here is easy for all parabolas. We can see that this graph continues extending out to the right and it continues extending out to the left. So that means that x can be any value. X is an element of the reals because x just keeps on extending out and getting bigger as we move to the right and smaller as we move to the left. The range for our quadratic functions is the tricky one. Okay? So our y values, y always has to be, in this case, less than our maximum. Okay? Because as we extend upwards, it stops at that maximum point and never extends past that maximum point, and then the y values keep on going downwards. So our y value can be a very low number, but it has a maximum value at that highest point of our parabola. So our y needs to be less than our maximum, less than or equal to our maximum. Other than that, it can be an element of the reals, but it has to be less than our maximum. And if we want to determine our maximum, we can go into our graphing calculator and we can press second, trace. We can scroll down to the number 4, maximum. And that says left bound. So we're going to go to the left side of the maximum. We're going to press enter. Then we're going to go to the right side of our maximum and we're going to press enter. And then we're going to press enter a third time and it will give us our maximum value. So this is telling us that the maximum value happens when x is equal to 0.5 and y is equal to 4.5. So if we wanted to be really specific here with our range, we could say that y needs to be less than or equal to 4.5. That's the highest possible y value in this function. And other than that, y can be any real number. The number of turning points is the number of times that the graph or the function changes its directions. So it's going upwards and it changes directions once and it starts moving back downwards. So we would say that this graph has 1 turning point.